Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're watching on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a Q&A button. Click on that, type in your question, hit submit, and I'll get to those at the end. If you're watching on YouTube, just feel free to use the live chat function wherever that happens to be on your screen on your device, and we'll go through those comments and questions later on as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. Then about 30 different Snap-on franchisees I work with, as well as their shop owners and shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So worked in a dealership, and over time, I guess, just became that default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type problems that would come into my day. And before that, a bunch of other miscellaneous wrenching jobs. Spent a little over 25 years under hood experience for me. So our topic today is auxiliary emissions systems, operation and testing. So this is going to be a lump of multiple other systems that really this is not a lot to talk about for half an hour on each of them individually. So we brought a lot of them together into one kind of one summarized or one common class that we can have on these different items. So things like the EGR valve, we talk about EGR valves a couple other times in other classes as well. Air pumps, variable runner intake manifolds, tumble generator valves, and displacement on demand, which is known by a couple different names, and a couple of different manufacturers use these. Now, these are the emissions devices that aren't on every vehicle. Some vehicles have them, some vehicles don't. Some manufacturers never used one. Some manufacturers use them on every car. Just really depends on the manufacturer, the application, and so on. So let's go through an overview of how they work and a couple different real world examples on the tool as to how we would go about testing them and taking a look at them as we go through. So first one's EGR valve, and that's used on both diesel and gasoline engines. I know we talked about it in the diesel emissions class, but it's also used on gasoline engines, of course, as well. It's used to reduce cylinder temperatures. So that reduces NOx emissions. So what it does is it takes some of the exhaust gas off and pumps it back into the intake on the engine, and being an inert gas, it'll help us reduce those cylinder temps, which once again reduces the oxides and nitrogen from forming, which reduces emissions. Not as much of an issue on a gasoline engine, I don't really feel nowadays. They still have some cars with EGRs, but some cars can get by fine without them. Diesel vehicles for sure can have a hard time dealing with some of the NOx emissions. So they have EGRs and SCRs and all that to try and take care of that and reduce that. Now they can vary from full open to full closed and anywhere in between. They could be vacuum operated or electronically operated, or more your modern valves will be. So the older style, we're going to have an EGR valve there. We see that on the top of the screen. And then we have our intake manifold where you can see the exhaust gas going in. Here's my engine, the combustion chamber. It goes out the exhaust, and then tapping off that exhaust gives us a little bit extra of that exhaust gas goes through that EGR valve and back in. Now, in this case, it's vacuum controlled. So this has an EGR control solenoid on it. So it's going to tap into the vacuum on the intake manifold, and then it's just a solenoid, opens and closes. Can be variable too. You can use pulse width modulation to open and close it a little bit or a lot, depending on where we're at, and we can step through it. And then it just actuates the vacuum over here on this diaphragm, opens up, pulls this pintle off the seat, and that's what opens the door, so to say. And then on a electronically operated one, this one also has an EGR cooler as well. On an electronically operated one, it's a stepper motor, so it pulls it up and down depending on how much of a duty cycle the PCM provides to this. As I want it open 30%, it'll open 30%. EGR cooler is important so we don't have really hot exhaust gas going into this. We don't want to melt anything or have too high of an exhaust temperature going in there as well. So as I said, we can have two different styles. We're going to have our vacuum style and then our electrical style. So on the vacuum, there's a little closer look as to what we have. Exhaust comes in the bottom. We have this pintle. tapered pintle onto a seat. When this is down and closed, exhaust gas can't flow by. When it's opened up by using vacuum here, pulling up on this diaphragm, it is able to open up, and then the exhaust can flow by. And depending on how much it's open, the more it's open, the more exhaust gas flows. Very similar look on the right-hand side with the electrically operated one, except it is a motor. And more often than not, they will have a position sensor along with them. So in this case, it's like a pretty much like a throttle position sensor, where it's going to be a variable voltage depending on how open it is. And then we have the electromagnet around the outside, because that is the variable motor cylinder stepper motor thing. Once again, exhaust comes in. We have a tapered pintle seat, and then the exhaust comes out that way. Now, some problems we can have with EGR, it's pretty common, is carbon buildup in there, especially on diesel vehicles. Diesel vehicles, the exhaust is not quite as clean as on a gasoline vehicle, of course. So you get a lot more soot on there. But the pintle will stick in the carbon. And then also you can have failed relearns due to carbon too. So if you have an electronically operated EGR valve and you need to do a relearn, what happens is, if we look at a closer look at this, when that pintle opens, when it does a relearn, it'll pull that pintle open and close. So it brings it to max travel on either end. And then whatever the bottom of that is closed according to the computer. So it'll pull it up. And let's say when it does pull it up, a little bit of that carbon that might be in there shakes loose. Then it gets caught, let's say right in here. It gets caught. It's kind of like a little piece of a red arrow right there. So let's imagine that's just a little piece of carbon in there. And then when it closes, it gets stuck. When it's stuck in there, that pintle cannot close all the way. It can't seat fully. But according to the computer, that's closed. Next time it goes to open it, maybe that little piece of carbon falls back off and it goes out into the exhaust or into the intake. And then I don't have that carbon there. And then it goes down to what the computer thinks is fully closed. Being as that carbon was keeping it from sealing fully, now we have a leak. We have a bit of a leak. So that can cause drivability problems, especially if the computer thinks that it's closed when it really isn't closed. It just learned that with that carbon buildup in the way it was closed, and the carbon went back. So just something to keep an eye on. I've seen that many times where it fails or it passes the relearn, just the computer doesn't realize that that's the problem, and then you end up with a little leak right there. So definitely something to look out for from drivability problem on an electric EGR vehicle. Next thing is an air pump. So we've been using air pumps since the 1960s on vehicles. We have mechanical ones back then, and then nowadays the modern ones are electric. Adds high pressure air to the exhaust. So that helps lean out the exhaust in a way. It's allowing more oxygen into the exhaust and allows the cat to reach temperature quicker, allows it to light up faster, blends with the hydrocarbons, and allows it to light off a bit faster. So it decreases the amount of time it takes for the cat to start working. And as we said, it could be belt driven or electric. So here's an example of a belt driven one. We got a pulley there. We got the actual air pump there. And then I remember back then we had these different valves. And we had the air pipes, AIR pipes that would go into the exhaust manifolds right there. So this is on a V8. Of course, we'd have 4 on either side, bracketry and all that good stuff. So I remember these back. I worked in a parts store for a while. So sold, I need an air pump. I need one of these rails or what have you. It's just kind of the way they did it back from the 60s through, the 80s. So they went to electronics at that point. Here's an electric air pump setup. This is off a Subaru. So we have the electric air pump. In this case, it's off to the side. And then it has a hose that goes in, splits off because it's horizontally opposed in this, the way the engine's configured. Then we have these 2 solenoid valves, which are variable solenoids. And then they have metal pipes that go down to the back of the exhaust ports on the engine there. So there can be failures in these systems, especially on these electrically operated systems. So they are prone to water intrusion, or maybe it's more correctly would be the condensation in the exhaust gets in there and it keeps getting in there and gets in there and gets in there. And over time they seize, they corrode. I got a couple pictures on the next slide that'll show you about that. So common codes related to this, it's going to be P0410 and P0411, depends on the side. One's driver's side, one's passenger side. So here's an example of a corroded valve, one of those valves there, and it just got a bunch of crud in there, rust and whatnot. And then here's a pump itself that got all sorts of moisture in there, and they just fail. They'll seize up, they'll get corrosion, what have you. So that can be a major cause of issues with these electric air pumps, because they seem to put them kind of low on the vehicle too, so the condensation has a better place to go downhill. Right, so that's just a couple examples of what you might see. Next one's variable runner intake. There's a couple of manufacturers that use these a few different ways. It's different actuators and such. So in this case, we're looking at BMW, one of BMW's systems. They call it DISA. So what it does is it changes the intake air path and allows the torque to vary depending on the load. So when I'm on a low RPM, I want to have a long intake runner path to give me that low RPM torque. Mid-range RPM, you'll see in this system, we still have the long runners, but we open a shorter runner as well. And that also allows the back pulses that come back out to flow back in as well. And then at max high RPM, it opens a third valve, and that allows the shortest path through the back pressure as well, the back pulses. I remember I had a 94 Acura Integra, and it had something like that. So it had a dual plane runner. One was longer, one was shorter, and then it just had a butterfly valve in the middle. Would open up the butterfly valve for the short and then close it for the long. So that's just how that worked. So it allows it to vary. And then also on BMWs, they had a infinitely variable, we'll call it infinitely variable runner intake. So it's kind of a big intake because it's got this circular thing in here. It's got a rod that goes in. It's got an actuator that can turn it infinitely through a degree range. So it'll go from the longest to the shortest depending on what the needs are of that vehicle at that time. So it can go backwards and forwards and open and close. And due to the configuration of the ports in here and the pathways, it'll either be a long runner or a short runner and anywhere in between. So that's another instance of that variable runner. There's others like I think Hyundai uses, just like that one I described on the Acura, where it's got two ports and it opens a butterfly valve. Semi-related to that is going to be tumble generator valves or tumble generation valves or whatever you might want to call them. What they do is they increase swirl or tumble in the intake system, which in turn helps increase combustion and efficiency, especially at low RPMs off idle. Increases the low and mid-speed torque by doing it this way. So if we take a little bit of a look here, normal airflow is with this butterfly valve right here. It's open. It's just going to flow in and swirl how it normally is designed to do so. Over here, we have the valve closed, or at least in the closed position. It doesn't fully block the path. It just blocks maybe 80 or 90% of the path, which forces the air to speed up going through this little port here. And then it increases the amount of tumble and flow in there. Now, this is off a Hyundai. A few other manufacturers use this. I know Subaru did, and I believe they still do. But on the Subaru, is at the bottom of the intake manifold, and there was looked like a riser plate at the bottom of the intake manifold on both sides, and then had actuator stepper motors, which would turn them on or off. And then on the other side there was a rod that went through. On the other side, it looked like a throttle position sensor. Is basically all it was. It's just a position sensor for that. On the older versions of the vehicles, like mid 2000s, 2004, 2005, 2006, on the vehicles they use that, it would just be a one and done. So when I turn the switch on and I'm at idle, it's going to do tumble. Soon as I stepped on the accelerator pedal, it would flip them open and that'd be done until the next time you cycle the key. Other newer styles on that, what they would do is they would close at idle. You step on the accelerator pedal, move the revs up, they'll open up, and then they'll go back. So it just depends on what the load and how the manufacturer decided to program the valves to work. But there are a couple different ways that that'll operate. In this case, this is off the Hyundai as well. So they call this a variable charge motion actuator. This is what that VCMA is right there. And that's just a stepper motor with a couple levers on it. You see it mounts to the intake over here, and then it's got the little lever. It cams up or it cams down. And then we have the lever arm there that it attaches to. And then we have those flaps that partially block the intake manifold there. So that is variable or tumble generator valves, not variable, but it's semi-related to a variable intake. And then now we have come to displacement on demand. So I know GM calls it displacement on demand. They call it a couple different things, but there are other manufacturers that use it as well. It cuts out some cylinders on larger engines. So if I have a V8, it'll cut out half the cylinders when I'm cruising. Or 3 on a V6, there's actually a couple ways that like Honda does this. So Honda does either they'll cut out a whole bank or they can cut out just 2 cylinders and run as a V4 as well. Either way, we're turning off cylinders when we want to, or when the manufacturer wants to, or when the computer decides that it needs to, which helps us increase the fuel economy at cruising speeds. Because if I'm cruising 65, 70 miles an hour or whatever, I don't need a big V8 power to just keep me going steady state down the highway. When I need to go up an incline or something like that, yeah, I do. So then it'll turn back on. But it helps increase the fuel economy overall. So here's an example of Honda's 6-cylinder displacement on demand. They call it something else, but idling we're in 6 cylinders, and then because it knows we're probably going to want to accelerate, so it gives us 6-cylinder drive there. Then I'm cruising, and then it shuts off. In this case, it shuts off half the engine, so it shuts off one of the banks, and then it just cruises that way. Then when I decel, it's fine. I still don't need the power decel. And then when I'm cruising again, I don't need the power. Then I decel, I don't need it. Then once I get back down to idle, it'll go back to 6 cylinders just because it knows it's probably going to need some power to get back up. Then it gets back up, same thing, goes to the 3-cylinder. In this case, we're also, we're jumping from maybe 50 miles an hour to 70 miles an hour or something like that. It turns on an extra cylinder. So it goes from 3-cylinder to 4-cylinder drive, and it's up here. So it has a couple different ways that it does it. It'll either do a 4-cylinder or 6-cylinder, 4-cylinder, or 3-cylinder, depending on the vehicle. So in this case, this is the, it also has variable valve lifts and variable valve timing, so the VTEC on it. If you want to watch the variable valve timing lesson we did, learn more about that. But here's a high lift mode, here's low lift mode, and then there we have 3-cylinder mode where it cuts out 3 entire cylinders, so 1 bank on the engine. Works with these rocker arm oil control valves. So it's very similar to how VTEC works. It works alongside the system. You can see on each of these rocker arms, we have these pins, and they're held in place with a spring. When those springs are locked together, it'll ride on the camshafts as it's supposed to do, and then just open and close. Now it can ride on the high lobe or the low lobe, so there's additional pins for that for the VTEC system. But this is just for the cylinder shutdown system. So we got on number 1, 2, and 3, so we can shut off the whole bank here. This is normal operation. All the pins are in place, being pushed in by the springs. We have these oil control valves that'll do some stuff on either side. In this case, we're on 4-cylinder operation, so it'll just turn off a couple cylinders. We see the oil pressure comes in here, turns off this cylinder right there. Oil pressure comes in, compresses the spring. At that point, when I've compressed the spring, it's just kind of idling on the cam, and it's not using those rockers to open the valves. It is just sitting there. It's not pushing on anything. That little idler is just idling. So it'll do cylinder 3, and it'll do the companion cylinder on the other side. Then we go down to 3-cylinder operation. Oil flow goes through all of these cylinders, pushes all the pins, and all the rockers act in that idle state at that point where they're not moving at all, just the idlers following the camshaft, not opening the valves at that point. So that's an overhead cam engine. That's how Honda would do it. GM also has a method of doing it. So on the GM motors, though, it's a push rod. So we have the rocker or the little roller there on the camshaft, and it's going to push that push rod. You see, I got this pin right here with a spring. So these pins hold the outside sleeve to the inside part. When they're locked together, the whole thing moves up and down as a unit. So the push rod moves up and down as a unit, and that allows it to open and close normally. You can see the outside there. You can see where the pinhole is. When we want to turn off some cylinders, once again, it's an oil-controlled solenoid valve. Oil pressure goes in, pushes against the springs, pops those pins out. So now the outside can open independently of the inside. So the inside basically stays in place, and the outside slides over that inside part, allowing it to follow the camshaft but not push the push rod. So in effect, those valves are all closed and they're not able to open at that point. So it can turn off those particular cylinders. Now, this is kind of the old way they did it. I suppose they have a couple of different ways of doing this now. But they also have this other thing that came on more recently called dynamic skip fire. So what that does, depending on the torque demand, and this is GM, by the way, depending on the torque demand of the motor, it'll just skip firing some of the cylinders on a V8, for example. So it can go down to like a 4-cylinder, just not fire the cylinders. Instead of using all that mechanical stuff, it actually has the computer figures out, okay, based on the demand, how many cylinders do I need to fire this time around? And then it'll either fire them all or it'll fire some of them. And it just depends on the torque demand. So that's kind of an interesting way of doing it. Not really mechanical, it's more electronic in that way. Now, another interesting fun fact, I guess you could say, based on some of the chip shortages that have been going around. I talked to a tech that used to work at a Cadillac dealership, and he said, "Oh yeah, the last few years anyway, they haven't been able to get the chips to operate the displacement on demand system. So they actually came out with a new RPO code, new option code, where it would have everything but that on the vehicle. So there's certain vehicles running around out there that are supposed to have it, but they don't have it because, well, they didn't have the chips for it. And waiting around for one chip on one processor for one system, I think if you're going to cut out one system on a vehicle and either sell it or don't, that might be the one that the manufacturer wants to go with, right? So there are some out there. So just FYI, you may run into one of those at some point. You think it's got a problem with this, maybe it's a drivability problem related to, maybe it's a displacement on demand system, but it's not because it doesn't have it. Although that's supposed to, but it doesn't, just because of the year range. Don't always trust that year range. Is what I'm trying to say, I guess, because there may be vehicles out there that do, and maybe vehicles out there that don't. All right, so let's look at a few things on the tool. A couple different systems that we can look at. First one I wanted to look at today, I got this 2017 Toyota Tundra with a V8. So that has a couple different systems in it. First one I want to look at is I'm going to go into guided component tests. So if you have a snap-on tool with a scope in it, so that'd be Modus, Triton, Varus, Zeus, Verdict, Vantage, any of those tools have the guided component test database. I got the 2017 Toyota Tundra, so we're going to go into the engine and see what we got. Well, first off, we got the air injection system. So if we go to the component information, in order to reduce cold engine emissions and warm up the three-way cat quicker during cold engine operation, engine coolant temp between 41 and 104 degrees Fahrenheit, an air injection control system has been added to this model. Secondary air injection is supplied by a DC electric motor driving an impeller. Air injector control driver controls air pump under direction of the ECM. Clean air enters the pump through the air filter. Downstream of an air pump, pressurized air enters two electrically controlled air switching control valves with pressure sensor. When ECM command switches air switching control valve open, air is supplied to each bank through air injection port in the exhaust manifold. Air injection pressure and exhaust gas pulses are monitored by the air pressure sensor. Sensor may also be called a turbo pressure sensor, I guess, if it had a turbo on. So we have a couple different things we can test. So we're going to go into the air pump. Air pump's activated by the ECM to add oxygen to the exhaust stream. We just read about that. Air pump is on the left side is for bank 1, right side for bank 2. So this one has 2 air pumps as well. Then we can see the pin assignments there for the pumps themselves. And if we come down here, we got heaters as well for the air injection solenoids. Electric air pumps can be tested at the 2-pin injection connectors. Connectors located near engine room relay box. And then electric air pumps part of the air pump assembly and is located in the right front fender area. So it tells us a lot of location information, pin assignments, wire colors, etc. There's a functional test for it. So you can go in. Continued air pump functional testing can cause pump overheating. Limit testing to no more than 4 attempts, 5 seconds each with a 30-second interval between tests. If needed to test more than 4 attempts, let the system cool for up to 10 minutes. We don't want to overheat it. And we can access the connector and we can see, do we have 12 volts? Do we not have 12 volts? Do we have power? Do we have ground? And so on. Back up. And we also have a resistance test there as well. So we can check the resistance of the motor. So you can take the red and blue test leads across the 2 smaller heater terminals. And we're going to see the resistance in there as well on the air pump. If I back up, we also have the air switching valves, which are our solenoids that open and close. So using the air injection system to allow or block air traveling from the air injection pump to the exhaust stream. use of the solenoid replace the prior use of conventional check valves. Electrically controlled valves used to open and shut air pressure between electric air pump and exhaust manifold injection tube. You can see the bank 1 and bank 2 pin assignments. Depending on how the vehicle is set up, looks like they got a couple different varieties in there. And then they're on each valve cover as well. So this should be fairly easy to get to. And then once again, those have a functional test that we can get to. Open, it basically opens and closes it. And then resistance test tells us the resistance should be 4.5 to 5.5 volts at room temperature, I guess, 68 degrees. This is the air system. And then this one also has, there we go, intake manifold runner control solenoid. There's an actuator and a control solenoid. So this one's got variable runners as well. Actuators used to vary the intake runner length based upon engine load. And we can check it there. That one's vacuum operated in that case. Let's take a look at the scanner and see what we can do in there. So I went in the engine system on the scanner, and we have the secondary air injection system here. We can do a manual check, and we can do an automatic check where it runs through it for us. This function is used to determine malfunctioning parts of the air injection system. Uses to identify the components that may cause a malfunction or validate the repair of air injection system. So this says, let's do it beforehand. Let's test it, check for failure. And let's do it after the fact, after we repair the system, make sure it works properly. So it's automatic. This mode will simulate the system monitor if a malfunction is present at a total step. Confirm the vehicle stopped and engine is idling. And it's going to go through the automatic function, and then it's going to tell us whether it worked. In this case, we did an error because I'm not hooked up to a car. So it couldn't activate the air pump because I'm not hooked up to the vehicle. But it's going to tell us how to reset it too if we need to as well. Then we can do a manual function where it's going to step through individually as well. So that's for the air pump system. And then also in here, we should have some actuator tests that we can do. So related to today, with the intake control valve, that's for the variable intake manifold. And then let's see, looks like that's about it in here. Yes, that is it. All right, so that's our Toyota, those air pumps and such. Next one, we'll look at this Hyundai Santa Fe, which has the tumble generator system. So that's in the engine system as well. Tumble generator actuator, tumble generator sensor. So the actuator, it's going to say tumble generator system utilizes an electronically controlled butterfly valve in each intake runner port. At cold idle, the tumble generator system will redirect the air charge through the different port. These ports have a finish characteristic that causes the air-fuel mixture to swirl and tumble greatly and create better combustion. This results in greater idle quality, cleaner emissions, and easier cold starts. Once the vehicle warms up, the tumble generator system will be deactivated, and the intake air charge will be directed through the standard intake port. Hyundai calls this component variable charge motion actuator. The ECM and PCM controls the monitor on-off state. Best place to test it is at the actuator harness above the throttle body, and the actuator is installed in the inlet hose of the intake manifold. So you can see the pin out there again. We can do a DC voltage test. It's going to give us our plus and minus, and key on. Voltage should be about 1.8 volts. If I do the sensor, I said that should be like a voltage sensor. So it should be approximately 1.7 at idle and 3.2 volts from a closed to open status. So as it goes open to close, should be 1.7 when it's closed and 3.2, I guess, when it would be open in that case, because closed would be when it's actually operating. So it goes from 1.7 to 3.2. So that's a 5-volt reference. So that's tumble generator. There's also should be an actuator test in here as well, I believe. The scanner. And that'd be functional tests. A lot of stuff in here. So a variable intake solenoid right there. And that's just going to be a start and stop. So it's going to be an open and close type situation. So do I close it? Do I open it? And then we can see the data if we need it as to whether we get feedback, whether or not it opens. Let's see what else we got. Do you have anything else in here? I think that was it. I think that was it. All right. So that is tumble generator. All right, let's look at EGR. So this Chevy Impala has EGR and an EGR position sensor. So we should be able to go in here, EGR system, and with the component information, 5-wire EGR receives ignition positive from the EGR control. The PCM uses pulse width modulation on the EGR minus to obtain desired pintle position, and the EGR has a pintle position sensor to monitor actual pintle position. A 3-wire sensor receives PCM and ground, and it supplies a position signal to the PCM. So we can see it's got position and plus and minus. So we can do a DC voltage test. Key on engine off should be 0.15 to 1 volt. As the EGR valve opens, to sweep from about 0.5 volt to 5 volts with no dropouts or glitches. So what we'd want to see on that, in that case, let's say I wanted to test the voltage on that. We're going to go and show what that would look like. We'll hit view meter. So we hook up to the position sensor. We should see about 0.5 volt, I guess it was supposed to be, right? About 0.5 volt there when it's closed. And then if we sweep it all the way to open, we don't want to see it drop out or glitches. That's up to 5 volts back down. Now, what if it came up like this and I had a dropout? That's bad. So it means my EGR position sensor is not working properly. I can also do a duty cycle test if we wanted to do that. So that'll be checking the duty cycle on the EGR solenoid. So with warm engine, snap the throttle, check that on time or duty cycle is present momentarily, and then turns off. For best results, the vehicle should be driven to activate the EGR system. So you'd want us to be able to see the duty cycle, which I'm way up. I'm confusing my machine today. So that gives us a percentage of on time. There we go. Oh, my knob is busted. My knob is not working anymore. Okay, found a glitch. Anyways, this gives us our percentage of on time. So if I were to command it to 10% of on time, let's say 40% of on time, I could command it to 40% of the on time, and I would see it right there. And it would go up and down as I command it up and down. In this case, it's not going to because my board is not working. But we'd be able to see it if it was 90%, it would go up to 90%, 80%, and so on and so forth. Now, how would I command that on? So I can go and do this through the scanner. So if I go back to the scanner, so I can do these tests, depending on my tool, I can do these tests easier by doing a functional test on one side, which in this case in GM would be an output control. And then we have the EGR percentage. So in this case, we have our percentage there, and I can just go up 40%, and I'd be able to watch back on the guided component test. Where is it? Well, there, right there, it's at 40%, so that's good. Now, what if I wanted to see it on the same screen at the same time? I could do that too if I have a Windows-based tool. So on a Windows-based tool, I can have multiple windows open. So I'm going to go up to my meter, make it full screen, go to meter again. It's going to turn it into a window. I can then go back to my scanner, have my controls here, down at the bottom, pull up my scope viewer, and snap it to the right, snap this to the left. I can move it up and down. So right here I have 40%, I see 40%. If I move it down and command it down and it doesn't go down, then I know we have a problem there. If it does go down, which it may or may not, stick with me here. Here we go. So it goes down to 10%. So let's say I had it down to 10%, you'd be able to see it step down to 10%. So being able to control it on one side and see the result on the other side is a very handy feature that we could do as long as we have a Windows-based tool. If we don't have a Windows-based tool, we can flip back and forth and we can see what it does. Or if we have two tools, some people like to have two tools and they can switch it back and forth that way. And the last thing I want to get into is that BMW with the variable intake system. So going to guided component test here. It's a 750i. And we had variable intake system. So the operation of the variable intake manifold is controlled by a powerful output stage located inside the ECM. Power and ground come from the PCM. Intake runners are lengthened or shortened by a rotating rotor, which is turned by a 12-volt DC motor. When the 12-volt motor rotates the rotor, the length of the intake runners is changed, and any intake length can be set between the two end stops. So anywhere between full and maximum minimum, anywhere between, it's able to do it. 12-volt DC motor with a worm gear mechanism. Potentiometer provides precise position at all times for the variable intake runner. The control is mounted on the back of the intake manifold. You'll need to remove both lower microfilter housings and the engine bulkhead, which is mounted to the firewall, in order to gain access to the intake manifold control motor. Sounds like it's buried just like just about anything else on a BMW, right? Motor replacement is necessary. You'll need to disconnect main engine harness from various sensors and actuators surrounding the intake manifold to gain enough flex in the harness to remove the intake manifold motor from the vehicle. And then in this case, we can do a signature test. It's going to give us our plus and minus. And if we go down here, here's what it should look like. So it should look like a 14 volts positive to 14 volts negative square waveform. There's a delay of up to 90 milliseconds for the waveform to invert. So you'll see a flat line for up to 90 milliseconds before you see the waveform invert. So that would just be a square wave pattern. You'd see 14 volts max down to 14 negative volts. So it actually goes on either side of that. So you'll be able to see that. So lots of interesting things that we can do. Lots of different tests that we can do on these functions on these vehicles. And like I said, it's not on every single vehicle. So just being aware that these systems do exist on some vehicles, it could help you out when you're trying to diagnose one of those pesky drivability problems that just can't seem to figure out and say, oh, well, my intake runner was stuck. I didn't even realize that that was a thing, right? So hopefully you got some tips and tricks from that. Let's talk about, oops, wrong button. There we go. Let's talk about what we're going to talk about next week. So next week, we are revisiting thermal imaging. We have some new recordings and new snapshots and new interesting things that we've read our thermal imager and used our thermal imager to diagnose on vehicles. So some pretty cool stuff. Hopefully you can join me for that. Always good to be able to see the unseen when I'm trying to diagnose a pesky problem on a vehicle. So that's next week. Same time, same place, every Tuesday, 6 and 9 Eastern. If you want to join me on Zoom, go to snapon.com/OT to reserve your seat. Otherwise, the 6 p.m. Eastern goes to YouTube and youtube.com/SnapOnDiagnostics. If you are watching on YouTube, please thumbs up and subscribe and ring that notification bell so you'll know anytime we go live or post new material. There is going to be a lot of new material coming down the pike here in the next couple months. So definitely something you'll want to watch out for. If you want to watch any of our previous topics that we've done on this live stream training, anywhere from ADAS, data bus testing, component testing series, HVAC, etc., make sure you check those out on our YouTube channel as well, youtube.com/SnapOnDiagnostics. There is a playlist for live training. So 43 episodes. This is number 44 right now. We're getting up there. We'll hit 50 by the end of the summer. Pretty cool. All right, let's look at questions. Looks like we don't have much going on Zoom. If you do have a question on Zoom, just hit that Q&A box, type it in. On YouTube, I do see we got some chatter in there as well. So we'll talk to you in a second. Just want to make sure everybody's aware that my buddy Al also does live training. It is more of a hands-on type. You take your tool and put it in front of you, follow along with what Al's doing on his screen, on your screen. And he does it on Zoom only. That way it's kind of a little bit more interactive as well. You can ask questions, get some feedback. Snapon.com/OT once again to register for that on Zoom. And it is a very comprehensive class. The Apollo goes through everything from let's set up your Wi-Fi through let's make sure we set up your free Snap-on Cloud account, all the way through let's walk you through code to completion, everything you need to know about Fast Track Intelligent Diagnostics, which also uses multiple functions of the tool. That's about an hour. And then on Wednesday and Thursday, it also has pretty much that same hour just on whatever tool he's working on. And then for a second hour on Wednesday and Thursday, since they have scope and meter functions, after a 5-minute break, you'll go through all the scope and meter functions on the tool, give you some real world examples, some good things to know. So definitely worth it. Al's been with us for a very long time. Definitely worth your time to check out that training if you want more information on a tool you may already have. All right, let's go at questions. Once again, Zoom looks clear. Let's go to YouTube. Looks like Abel's checking in again. Thanks for attending. And Nick, welcome back from London or UK anyways. Keith, wish I could spend more time on it. Yeah, it's they give me a half an hour, but I don't know if I could do half an hour on variable runner intakes, so we just kind of bring those in and just kind of keep them together, right? And EGR, when it gets into that deep dive on EGR, we get into chemistry and things like that. And we don't really need to know the chemistry, I guess. But I'm glad you enjoyed it. Hello, the Winton. Thanks for joining as always. And DJ, all hail thermal energies, talking about next week's class. with the thermal. Yeah, I'm guessing that DJ gets a lot of use out of his own thermal camera. So definitely appreciate the comments and questions, folks. Hopefully you got a little bit out of our different oddball auxiliary emission systems today. Picked up a couple tips and tricks that might help you a little bit later down the road. With that, thank you very much for taking a little bit of time out of your busy day. Spend a little bit of time with me. Hopefully picked up some tips and tricks. Hopefully you'll join me next week for Thermal Imaging Revisited. Like I said, we got some cool little videos that we have I'm not going to spoil what it is, but we got some cool videos that we added in there as well. A couple new systems, a couple old systems. We're going to revisit some things as well. So definitely worth the visit. Hopefully we'll see you next week. Enjoy the rest of your week. Enjoy your weekend. Take care.